are the properties of heart muscle? Explain them. 4 fundamental properties of the myocardium. 3 of electrophysiological nature, automatism, conductivity and excitability. And 1 that divides into 2 of a mechanical nature, contractility and relaxation. Automatism, chronotropism, ability of the heart to generate its own electrical stimuli, regardless of extrinsic influences to the organ. The area of automatism represented by the sinus node. Conduction, Dromotropism, conduction of the electrical activation process throughout the myocardium, in a systematically established sequence. This complex, called excito-conductive tissue. Excitability, Batmotropism, is the ability of the myocardium to react when stimulated, a reaction that extends throughout the organ. The extra-answer is called extraassistant. Contractility, Electrophysiology, it is the property that has the heart to actively contract as a single whole, once stimulated its entire musculature, which results in the phenomenon of systolic contraction. The myocardium always responds obeying the law of all or nothing. Relaxation, Electrophysiology, it refers to the global relaxation capacity that the heart has, once its electrical stimulation has ceased and, as a result, the contraction process is over, which determines the phenomenon of diastolic relaxation. What are the electrophysiological properties that characterize sinoatrial node, or node, cells as pacemaker cells? In resting conditions, cardiac muscle cells depolarize spontaneously without any external stimuli and generate an action potential approximately 80 to 100 times per minute. As a result, electrical impulses from the sinoatrial node propagate to this area and stimulate them more frequently, so that they do not even generate their own potentials of action. Thus, the sinoatrial node discharge rate determines the rhythm for the heart, and for this reason the sinoatrial node is considered the cardiac pacemaker, determining the origin of the electrical impulse that will trigger the contractions in the cardiac muscle cells. The contractions initiated at the sinoatrial node reach the upper regions of the atria and move toward the atrioventricular valves. This action will contribute to the movement of blood from the atria to the ventricles. 3. In relation to cardiac dromotropism, conductivity, what is the trajectory and name of the structures through which the action potentials that are generated in the heart's natural pacemaker are traversed? Potential occurs in the atrial sinoatrial node in the right atrium, passing to the left, completing in 0.1 seconds, activates the atrioventricular node in 0.17 seconds, and ends in the Purkinje fibers in 0.22 seconds. How are the phases of the action potential, AP, of the cells of the sinoatrial node and of the cardiac myocyte, identifying the ions responsible for generating the AP in each of the phases? 0. We can observe in the graph, in the opening of the fast sodium channels. 1. Opening of the potassium channels. 2. Opening the slow calcium channels. 3. Increased potassium efflux. 4. Reduction of potassium permeability. What is the importance of the atrioventricular node for the electrical activity of the heart? Electrically connects the atria to the ventricles, and has the action of conducting electrical impulse from the atrium to the ventricles, with a time variation, delaying in 0.09 seconds on average. What contributes and what is the functional importance of a long refractory period observed in the cardiac myocyte action potential? It helps to avoid tetany. In the absolute refractory period the cell does not produce another action potential. The other refractory period is relative, which requires a stronger stimulus than usual is needed to produce another action potential. How important is the Ca2+ ion to the electrical activity of the heart? The types of channels of this ion that participate in the action potential of the sinoatrial node are the same as those of the cardiomyocyte. To maintain the potential for action during a plateau, the potential action, or potential curve, between the sinoatrial node and the cardiomyocytes are different. What are the mechanisms of control of cardiac chronotropism? What is the system responsible for the control and the neurotransmitters involved in these adjustments? They are mechanisms at heart rate change. The system responsible is the sinus node. Relate each wave, P, Q, R, S, T, of an electrocardiogram to the record and explain what each one represents in cardiac excitability. P. Atrial depolarization. QRS ventricular depolarization. T. Ventricular repolarization.